On February 18, 2025, an asteroid called 2024 YR4 reached a 3.1% chance of hitting Earth in 2032, the highest impact probability ever recorded for an object of its size, a 1 in 32 chance. For most of the public conversation that followed, there was a quiet assumption sitting underneath the panic that somewhere amateur astronomers with their own telescopes were part of the watch, that if something this dangerous were coming, you could point a telescope at the sky and see it for yourself. That assumption was wrong, and the real reason why is the most unsettling part of this story. To understand why, you need to know what a Torino Scale 3 actually means. It's a real ranking astronomers use for exactly this situation. A 3 means a genuinely close encounter, worth watching carefully, but nowhere near cause for public alarm. And in general, amateur astronomers really do play a role in tracking dangerous asteroids. Plenty of fainter objects are followed by serious backyard observatories, feeding real data straight to the minor planet center. That's the textbook picture. This video is about the one time it broke down completely. And 2024 YR4's Torino 3 wasn't just any number. It was, at the time, the second highest rating any real asteroid has ever reached. The only object to ever rate higher was 99942 Apophis, which briefly hit a 4 back in 2004 before more data ruled out any danger. This wasn't a minor blip. It was one of the most serious ratings a real asteroid has ever earned. Here's the real timeline, with named sources. 2024 YR4 was discovered December the 27th, 2024, by the Atlas survey in Chile. By mid-February 2025, its probability had climbed to that record 3.1%. NASA's Center for Near-Earth Object Studies downgraded the risk within days, and by April 2nd, 2025, with a 91-day observation arc behind it, the chance of an Earth impact had been removed with high confidence. That same round of observations nailed down something else for the first time: the asteroid's actual size, somewhere between 174 and 220 feet across, roughly the length of a football field. Big enough that if the odds had gone the other way, this would not have been a minor regional event. Here's the part almost no one heard about. Ruling out an Earth impact didn't end the story. In May 2025, new Webb observations showed the asteroid's odds of hitting the Moon had actually risen to 4.3%. The threat hadn't vanished, it had relocated. Here's why, and it's not as strange as it sounds. Ruling out an Earth impact didn't erase the uncertainty in 2024 YR4's orbit. It just narrowed it. As astronomers gathered more data through the spring of 2025, the range of places the asteroid could actually be on December 22, 2032, kept shrinking. And as that range shrank, more of the remaining possibility landed directly on the Moon's position that day. The math didn't get scarier, it got more precise, and precision pointed somewhere new. So here's the question this video actually exists to answer. Not, is it dangerous, but could you, personally, with a telescope you could buy, have watched any of this happen yourself? Let's find out with the real numbers. 24 YI4's real brightness, around magnitude 24 as of mid-February 2025, about 7 weeks after its December 2024 discovery, then fading further to magnitude 26 by mid-March 2025 as it moved away from Earth. Then the real, standard amateur astronomy formula for what a telescope can actually see. Limiting magnitude rises by about 5 for every 10 times increase in aperture. It worked out, on screen, for real telescope sizes. A 70mm beginner scope tops out around magnitude 11.7. A serious 8-inch 200mm amateur telescope reaches about magnitude 14. Even a massive, club-level 12-inch scope only reaches around magnitude 15. Every one of those is roughly 9 to 11 magnitudes short of where 2024 YR4 actually was. And because each 5 magnitudes is a 100-fold difference in brightness, that means the asteroid was somewhere between 4,000 and 60,000 times fainter than the largest telescope you could realistically own. It required professional 8-meter class research telescopes and eventually the James Webb Space Telescope itself to keep tracking it at all. Ground-based amateur observation of this specific object effectively ended by March 23, 2025. There's a real reason JWST succeeded here, beyond just being a bigger telescope. Ground telescopes measure an asteroid by the sunlight it reflects, which means the answer depends on how reflective its surface happens to be, a real source of uncertainty. JWST's instruments instead measure the heat the asteroid itself gives off at mid-infrared wavelengths, which gives a far more direct and precise reading of its actual size. One ground-based visible light telescopes structurally can't match, no matter their aperture, and once its orbit was refined enough to calculate a real flyby distance, 2024 YR4's actual closest approach to the Moon on December 22, 2032, works out to about 22,900 kilometers, roughly 6% of the full quarter-million-mile trip from Earth to the Moon. That's a genuine, computed near miss on a planetary scale, and it's a number no telescope you could buy ever had any chance of confirming for yourself. That lunar impact scare followed the same pattern. New James Webb observations taken on February 18th and 26th, 2026, fed into a NASA announcement on March the 5th that finally eliminated even that chance just 4 months before this video, which means the most dangerous asteroid tracked in modern history played out almost entirely in a range no backyard telescope, no matter how good, could ever have shown you. Every person who felt reassured by astronomers are watching it was trusting instruments a home telescope has nothing in common with. None of that means a telescope is pointless for tracking real objects in the sky. It means most near-Earth object drama plays out far outside amateur range, and knowing that changes what you should actually buy one for. Real amateur astronomers do legitimately follow brighter, closer asteroids and contribute real tracking data to the Minor Planet Center, just not objects at magnitude 24. If you're looking to get started, a modest 6 to 8-inch telescope puts real, trackable, near-Earth objects within reach, just not the ones making headlines. This isn't hypothetical either. Real citizen science efforts like the Daily Minor Planet Project have led directly to the discovery of over 200 real main belt asteroids and 16 real near-Earth asteroids, with volunteers credited by name as official measurers in Minor Planet Center bulletins. That's what amateur equipment is actually good for. Genuinely valuable, genuinely real, and genuinely nowhere near magnitude 24. So the next time someone tells you a dangerous asteroid is being watched, remember what that actually means. Professional instruments, working in a range no telescope you could ever buy will reach. That's not a reason to worry less. It's just the truth about who's really doing the watching. Subscribe for the next one.